We're talking about something that's staggeringly improbable, roughly 1 in a trillion, 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 trillion.
Let all of life choose a million, a trillion, a trillion, trillion. The number is essentially zero. Something has to skew nature to choose the ones that work.
So, in the game of life, it looks as if the house always wins. Luckily, some serious scientific minds have figured out a way to beat the odds.
Directed panspermia.
When faced with the overwhelming problem of the origin of life, Nobel Prize winner Francis Crick proposed this theory, that life was seeded on Earth, which basically means aliens did it. Crystals? Aliens? I thought we were talking about science, not science fiction.
We don't know what caused life to arise. Did it arise by a purely undirected process? Or did it arise by some kind of intelligent guidance or design? And the rules of science are being applied to actually foreclose one of the two possible answers to that very fundamental and basic and important question.
So the rules of science say we will consider any possibility except one that is guided.
Exactly.
No matter how life began, on the backs of crystals or in the test tube of some intelligent designer, everyone agrees it started with a single cell. But what is a cell? Let me ask you a question.
Yeah.
Darwin wrote The Origin of Species in 1859, published it in 1859. He had an idea of the cell as being quite simple, correct?
Yeah, everybody did.
Okay. If he thought of the cell as being a Buick, what is the cell now in terms of its complexity by comparison?
A galaxy.
If Darwin thought a cell was, say, a mud hut, what do we now know that a cell is?
More complicated than a Saturn V.
So what is in a cell as far as we know now?
A world that Darwin never could have imagined.
I needed someone who could give me a glimpse into this world. So we went to molecular biologist Doug Axe.
Think of a cell as being a nanofactory, a factory where, on a very small scale, digital instructions are being used to make the components of the factory. Here we have the famous DNA double helix. You can see the two helical strands that are intertwined and wind around each other on the outside of the molecule. This is the material that stores all of our genetic information. In higher life forms, this will be the equivalent of something like a gigabyte of information stored in the molecules that form the individual chromosomes, all packed within the nucleus, which is a tiny fraction of the entire cell size. So what does DNA do? Well, the information in DNA ends up providing the information for sequencing the amino acids to make protein. We have information in a one-dimensional form that provides the information for a three-dimensional form.
I'm finally just beginning to grasp the complexity of the cell. Are there systems within the cell that go well beyond Darwinian evolution? Some type of cellular technology that drives adaptation, replication, quality control, and repair? What if these new mechanisms have massive design implications? Well, I say, so be it.
The cell really is like nothing we've ever seen in the physical world. That's got to be firmly grasped. That's not something we can just say, oh, well, it's just a little bit more of the same old, same old. It's not the same old, same old.
we are finding is that there's information that's in the cell that cannot be accounted for in terms of these undirected material causes. So these,
it has to be.
And so there's some other, so it has to be an information source.
So one of the key questions faced by modern biology is, where do you get information from?
Well, Darwin assumed that the increase in information comes from natural selection. But natural selection reduces genetic information, and we know this from all the genetic population studies that we have.
And where does the new genetic information going to come from?
Well, that's the big question.
So when we find